Hello. The aim of this video is to teach you something you already know, but to go through the steps very carefully. The hope is that by doing something relatively simple, with a lot of formality, the mathematical symbols we will use will hopefully be more transparent when we come to do more complex things. So without further ado, here we go. This is the first video in a series about probability that forms part of a university course. In it, you are going to learn about the so-called classical interpretation of probability. Hopefully by the end of this particular video, you should be able to explain how a subset of a finite set could be constructed by using a function to examine the properties of the members of this set. And you should also be able to explain the classical interpretation of probability using notions from set theory. Before we get on to that, I have a simple probability question for you. Imagine you play blind man's bluff with these 6 people. In case you don't know the game, you are first blindfolded so that you can no longer see. Your fellow players then all move around, and once they are done, you shuffle forward and grab the first person you come to. You thus pick a person randomly. My question for you then is this. Given this is the game, and given these are the people that you are playing with, what is the probability that the person you pick is female? Pause the video and take some time to work it out. Hopefully you were able to work out that the probability was 1/3. Take a moment to pause the video again and try to write out the set of steps that you took in determining this probability. It is this that we are going to go through in the remainder of the video. When we go through this problem with formal mathematics, our first step is to introduce a symbol to represent the outcome of the experiment. In this case, the person you pick when you play blindman's bluff. In statistics, we use capital Roman letters to represent these random variables. So here, for example, we are using capital X to represent the person we choose randomly during the game. Capital X can take one of 6 possible values. That is to say, it can represent each of the people that we could select when we play blindman's bluff. We call these possibilities the various outcomes of our experiments, and we call the set of them the sample space. In other words, the sample space contains the set of values that the random variable capital X can take. Now we could have it so that the random variable takes on the name of the person who is picked. But we are mathematicians and we don't have that much imagination, so we instead give each person a numerical value. In this case, we call Stephen 1, Conrad 2, Michael 3, Carlos 4, Maeve 5, and Dawn 6. In fact, when we do this, it's better to use the ordinal rather than the cardinal numbers and to call them first, second, third, fourth, fifth, and sixth. I say we do all this because we have no imagination, but that is probably unfair. We've developed numbers because we have a whole formal language, mathematics, for dealing with them. In fact, although when you're learning it doesn't possibly feel like this, once we can express a problem using numbers, it is usually simpler to explain and understand the problem and to hence find its solution. Having identified the possible outcomes of our experiment, our next step is to use a function to identify the females. The domain of this function will be the sample space, Conrad, Maeve, Michael, Dawn, Carlos, and Stephen, and the codomain will be the genders, i.e. male and female. Once again, we will behave like mathematicians and use numbers to represent the 2 genders, so 1 will be female and 0 will be male. Now, in mathematics, you learn all sorts of things about functions, and in amongst all the complicated things you can do with, say, smooth functions, analytic functions, and so on, it becomes easy to forget the simple definition for a function. A function is something that takes in an object, which we call the argument of the function, and that outputs another object. We say the function returns an object. We can thus represent a function using a box as shown here. If we consider the operation of this function, in goes Conrad. The function does its thing, and out comes a 0, which tells us that Conrad is not a girl. By contrast, when we put Maeve into our function, a 1 comes out as Maeve is female. Let's now perform this function on all the members of the sample space. We find that f of Stephen, f of Conrad, f of Michael, and f of Carlos are all 0, as these 4 people are all males. F of Maeve and f of Dawn, by contrast, are both 1, as Maeve and Dawn are both female. In this way, we can use our function to identify the subset of female members of the sample space. In this case, this is a subset containing Maeve and Dawn. We can express this process of forming a subset using the following mathematical nomenclature. When this statement is translated into English, it reads, and I literally am reading it from left to right just as I would a sentence, S is a member of the subset of females if f of S is equal to 1, and if S is a member of omega, where omega denotes our sample space. Remember in all of this that f of S is a function that returns a 1 if the argument of the function is female. The sentence I've just said is rather unwieldy, and as you can see, our set of mathematical symbols gives us a rather tidy way of expressing all these ideas in a considerably smaller amount of paper. With all this mathematical formality behind us, we are now finally in a position where we can calculate our probability. In doing so, we first calculate the cardinality of our sample space omega. This quantity, the cardinality of a set, simply tells us the number of members that are in that set. So for the sample space shown here, the cardinality of omega is just 6. We then calculate the cardinality of the subset that gives us the outcome that we desire. In this case, we want to select a girl, and we have learnt how we can denote this subset using the following piece of set builder notation. The cardinality of this subset is 2, as the number of people in it, the number of girls, is 2. We now introduce a definition of probability, a classical definition of probability, as the cardinality of the subset of the sample space that gives us the outcome we are interested in. In our example here, it is the cardinality of the subset of females. This cardinality is then divided by the total cardinality of the sample space. In this example, the number of people with whom we are playing blind man's bluff. Now, before I solve this problem, notice that when I've written this probability, the probability that x equals 1, I have changed the meaning of our random variable symbol capital X. Capital X can now no longer equal 1, 2, 3, 4, 5, or 6 to denote that I selected Stephen, Conrad, Michael, Carlos, Maeve, and Dawn as it did earlier. Now, capital X, can only equal 0 or 1. The probability that x equals 0 is thus the probability that I selected a boy, while the probability that capital X equals 1 is the probability that I select a girl. Returning to the question in hand, the probability of selecting a female, the cardinality of my subset of females is 2, whilst the cardinality of the sample space is 6. I thus have that my probability is equal to 2 over 6, which we all know simplifies to a third. So what have we learnt? We have learnt the formal way of solving a problem that you will probably be able to do quickly and easily. What is the point? Well, now that we understand what we are doing, we can apply this same procedure to more complex examples where things are perhaps not as simple. Let's thus summarize our formal approach to solving these problems with probability. We proceed as follows. We first define the set of all possible outcomes that we could have for our experiment. We furthermore make it so that all these various outcomes are equally likely. We then find the subset of outcomes that satisfy some criterion of interest. We can do this by introducing a function that returns a value of 1 when the outcome of our experiment, the argument of the function, has the property we are interested in, and that is 0. This function would be 0 otherwise. Lastly, we define the probability as the cardinality of this subset divided by the cardinality of the sample space. Easy. So in conclusion, you can hopefully now explain how a subset of a finite set can be constructed by using a function to examine the properties of the members of the set, and explain the classical interpretation of probability, the interpretation of probability that I've just explained, using notions from set theory. If you feel you cannot do these things, watch the video again and see if they're clearer the second time through. Thank you.